So good afternoon. Welcome to this webinar on cybersecurity and artificial intelligence. An interesting topic that we have been carrying already for quite some time within LSEC, and that we are planning to carry along and also towards the future. In actual fact, this is a continuation of something that we started already a long time ago. I think now for about 7 or 8 years, when we first took the stand with a number of AI technologies that supported typically our cybersecurity developments. My name is Ulrich Saldesax. I'm the Managing Director of LSEC, which is an association of IT security companies. And we've invited today a special guest, in this case, Stefan van den Borre from IBM. And he will be talking about their artificial intelligence solutions within IBM. But before I hand over the word to Stefan, let me share a couple of thoughts with you on why we are doing this. And more specifically, let me share with you a couple of slides on how this came about. So quite some time ago, we launched the idea about developing a project which is called Cybersecurity Artificial Intelligence. And it turned into be something of an actual activity and a project today. We do this from within our activities as Digital Security Catalyst, where we bring together both industry and end users and work together on how to further innovate with new technologies, specifically towards cybersecurity. That means specifically that we are focusing on using existing technologies coming out of academic research, but also implementing and utilizing new technologies coming out of the industry, implementing them specifically for the use of end users in particular. So about a year ago, we had one of the last sessions on this. In the meantime, we've done some others as well. We as participating in other fora, but here in this forum specifically, thanks to Ralph from G-Data, who was diving us into the artificial intelligence in cybersecurity in practice. And gave some indications, and you can still see the webinar on our website today, where these different concepts took into action. And it came about also because we saw that many of the largest cybersecurity companies are implementing and are utilizing on a day-to-day basis AI to further improve their products, technologies, but also the way they serve customers in particular. So both, in this case, Darkspace, as well as CrowdStrike, as well as many different others, are utilizing today's AI concept. And if we take quite a number of years back, we can actually see where all of this was originating from. And therefore, AI and cybersecurity have gone this joint history, typically from even the movie War Games dating back to the early 80s, where cybersecurity really took its stage off, also together with the AI concepts. Now, AI for cybersecurity, it has quite a number of interesting opportunities. We see today that cybersecurity has quite a number of challenges, and therefore the opportunities through AI. So the challenges are that there's actually quite a lot of complexity for people who are needing to work in cybersecurity in terms of analytics, in terms of operations. Since a couple of years ago, the difficulty increased with about 63%. And these numbers are coming from research which has been done in 2019 and 2020 on the way that SOC operators and incident operators are actually being utilized. And just put yourself into the controls of today's security operations center or even cybersecurity incident response. And it looks really a bit like a cockpit of a 747 with many different knobs and controls, but sometimes difficult for the operator to really know where he has to head to. So that means that there's actually quite a number of expectations. On the one hand side, we have to keep the bad guys out. On the other hand, we also have to make sure that the operations keep on running. And that's really where, in this case, AI should be of support to us. So we do see that there's quite a number of companies that are improving their own environments, specifically by means of utilizing AI components, and therefore reducing the impact of their incident management teams and the operators on their side. We see, for instance, as well as quite a number of other people that of course, AI doesn't only bring the good things within people, but AI is also being utilized by the bad guys, both when it comes to creating adversary attacks by using AI capabilities, but also using abusing AI in the same way that we are trying to abuse the mechanics and the calculation methods behind it and the mathematics behind it in order to basically reduce the capabilities of the AI to be most effective. And so just taking a look into the overall perspective, more and more companies in the space are utilizing AI technologies, and especially also for companies in cybersecurity landscape. And that's the reason why we started with a couple of activities under the brand name of Cybersecurity for AI. And we have actually an ongoing activity, a project, where we are trying to use all of these components and the capabilities of AI to really improve the cybersecurity activities for some of our member companies, as well as some of the end users within the environment. And so if we just take a look into what use case analysis could look like, and we can actually see that both from OT environments in terms of cybersecurity as well as IT, there's many different use cases already today. User behavioral analytics, machine behavioral analytics, scoring of specific risks in network environments, intrusion detection, where we can see that actually the AI components are really making a difference. And so this one is actually indicating that there's actually quite a number of high potential use cases by just utilizing the best way of AI. So in terms of a roadmap, we can see that today, while AI capabilities are mainly being utilized for today still machine learning, and then usually but slowly but surely improving towards the use of the machine learning to start to detect, and usually and also moving slowly also to try to prevent. And so we can see the deployment of things like SOAR is basically security orchestration, whereby AI capabilities are being used today and being deployed today to improve the way that the adversaries can actually be attacked. But it's also to train, for instance, the cyber analysts, or it's there to use basically the analyst in their day-to-day operations, for instance, by using bots in help functionalities. So quite a number of defensive AI capabilities. And we are focusing really on the use of behavioral analytics, the use of natural language processing, the use of machine learning, and many other components where we can see the direct use of, in this case, AI. And at the same time, we're also investigating the adversarial use of AI and trying to improve the AI systems by means of just understanding how the adversaries are utilizing it and improving it also at the same time on the behalf of the cybersecurity companies. So together with our partners from Distrinet, KU Leuven and COSI KU Leuven, VUB, the Artificial Intelligence Lab, and 3 companies, namely AccessGuard, Spotted, and Codex, we have deployed this project, which is now running until somewhere March of 2023. We'll be deploying a number of these technologies, and where our focus is really on trying to understand how we can best utilize the capabilities being offered by cloud operators, and whereby we can see how the AI capabilities, AIOps, but also the use of cloud-based AI services in terms of utilizing them to the best way for cybersecurity companies. And we started off by, of course, looking into what some of the analysts have been investigating already, and moving along from there, doing our own investigations in the capabilities of different AI services in the cloud. And in this session and in the next sessions going forward in the next couple of weeks, we have invited a number of these different cloud operators, Microsoft, Google, Amazon, IBM, and Alibaba, and working with a number of others, specifically when it comes to data science and machine learning capabilities. But as you can see, there's a number of companies that are returning quite strongly. And to start with, and that's how we'll kick it off today, IBM, and thanks to their basically their Watson platform, the cognitive platform from IBM, is really where we'll kick off this series of sessions today, and hopefully guide you through also with together with Stefan on what the different services are that IBM has to offer in AI capabilities. Starting, of course, by understanding a little bit better on what the IBM cloud offerings are, because that's really where we have to start taking it off. Stefan, good afternoon. How are you doing, sir, today?
Fine. Just dropped off, but I'm back.
Okay, that's fine. You're there, and that's a good thing to see. I think today is really a hot day in Belgium, as it's turning into 32 degrees, and it's even getting hotter because at 6 p.m. we actually have our Belgian national team playing. And you started already by sharing your screen. So I'll hand over to you, Stefan, to share with us IBM Cloud's perspective and IBM's AI perspective on this particular domain of cybersecurity and utilizing AI capabilities in the cloud for it. Thanks for doing it.
Okay. Thank you. So the point of this session today is actually to propose you, or let me call it the general AI tooling we have. We have, of course, very specific security-oriented tooling, but I think that's not the case. That's not the point of this education. I think there's a later one that will go more in depth on that. You see IBM Cloud here, but everything I'm going to tell you is available on IBM Cloud, but also on other clouds, and I will also explain you how this works. So I have 4 topics to cover. First, I want to explain you a concept which is named Cloud Packs, and it's actually a strategy of IBM, which is everything I show here deployable on any cloud that you have, on Amazon, on Azure, on Google, actually everything where you have a Kubernetes environment, you can deploy the tools I have here. Of course, they're also natively available on IBM Cloud itself. The next thing I will talk about the tools which support the AI lifecycle. Then the third one, more specific tools like chatbots and search engines and how they combine and how they work together. And the last session I want to talk about how AI is actually also an attack surface. AI can be used to counter attacks, but in itself, it's also an attack surface where people can use them and get benefits from. So first of all, what are the Cloud Packs? Cloud Packs you have to see as a cloud that you can deploy everywhere. Cloud-style, cloud-like deployment based on Kubernetes. And you probably all know that IBM has bought Red Hat, I think a year or 2 ago. So in our case, the Kubernetes environment that we use is Red Hat OpenShift. Now, on top of that, you see different, what we call Cloud Packs. And Cloud Packs you have to see as a bundle of collaborating tools with a very specific target. And you see at the right side, you see the security one. I will not talk about that one, but probably later on is possible. You also have a network automation integration, then AIOps one, business automation. I come back to the AIOps one, but I'm very specifically going to talk about the Cloud Pack for data one, because that one contains all the tooling that can be used in AI, the general tooling, but also, let's say, the chatbots and discovery. On the bottom, you see that we actually are able to deploy these Cloud Packs on any Kubernetes environment. And that means that the tooling I show you here is available on our cloud, IBM Cloud, or of course on your on-premise if you have an OpenShift, but also is available on AWS, Microsoft Azure, and Google Clouds. That's the idea that the strategy of IBM is actually hybrid clouds, to use it where the data is. So if you want to use these tools and you have a lot of data stored in AWS, it might be a good idea to use this tooling set and take it over there where the data is. This is insight in the Cloud Pack for data for security. I'm not going to cover those, but this Cloud Pack has a combination of security tooling that are working together. One of the most famous ones, of course, QRadar. QRadar, I think, is a well-known SIEM solution from IBM. But I'm not going to focus on this one. I'm going to focus on this one, which is called Cloud Pack for Data, which is a unified platform to manage and to govern and also to use data and in AI. So you see the different parts. We have a collect part, which allows you to combine different data and data virtualization and warehousing. The organize part, which allows us to classify the data, but also to govern it. Data it's important that you govern it, who can access it, you can anonymize it, and that kind of stuff is available in the organized part. Then we have the analyze part, where you have the classical dashboarding and reporting, but also the AI tooling. Now, what's not on there is noted on the right side. We also have an infuse layer, which actually contains our AI solutions, like our chatbot, Watson Assistant, and our enterprise search engine, Watson Discovery, and other APIs. And once again, you see below, it's available on our public cloud, on your private cloud, on-premise, everywhere you want to have this available. So the first thing I will talk about are the tooling that we use for AI lifecycle. And on the right side, you see the CRISP-BM, which is the traditional way on how you perform AI, starting from a business understanding all the way to a deployment of a model. The tooling I'm going to show you here is actually to support this CRISP-BM environment. So let's make a simple use case. Let's say that you have a lot of IoT devices which are spawning data, and you actually want to figure out if a certain IoT device is not hacked by something. And one of the things you could do is, for example, look at the network traffic. And if the network traffic is different from what would be expected from that kind of IoT device, if there's a difference, you can conclude, or it might conclude that it's actually a real threat and that the IoT device is actually hacked. So what we're going to do is we're going to look for and work with network data. And what we're going to do, we're going to try to predict based on the incoming data what type of IoT device it is, and then compare it with what it should be. So for example, in this case, if you have a television that it's sending and you predict the television, you might think, okay, it's not hacked. But for example, if you see the camera is hacked and it has very weird network settings, and you compare the settings what you expect from a camera, you can say, okay, might be a problem, and can shut it down, for example. So the first thing what you need to do is actually the process what you see here. The first thing you need to do is get your data. Where is your data? Is it available? Is it useful? Before you can actually start to look into it, to refine it, to manipulate it, to prepare it, to actually then give it to an AI modeling tool, which create a model. And then you have two phases left. First of all, if you have a good model, you can deploy it, make it available as an API, for example, or a batch scoring mechanism. And at the end, of course, you have to do the monitoring. Is the model still correct, or are some other issues available? The tooling I'm going to talk to you about is actually this whole chain in one combined into one tool chain that we provide to you. So the first thing what we can is figuring out your data. For that, we have a tool that's called Watson Knowledge Catalog. The catalog itself contains actually everything that you can put in there. But in our case, if you go to a data scientist, you can find in there all assets that are related to a data scientist might need. For example, of course, the data, but also models, notebooks, connections, actually everything that's in there. The backbone is what is much broader. It goes to also warehousing information and that kind of stuff. But let's say from our perspective, what we need is, okay, what data is available? Is it available okay? Are there already models made for me? Can I reuse some data? And that's what you can find here. On the left side, you see how it works. You have actually a search engine. I type in here network, and I see on the bottom that I have some IoT devices information. If I click on that, it's going to give me more information about this asset. And in this case, I get some sample data. What's in there, you see acknowledging the number of bytes that are sent over the network and that kind of information. You can also get a profile, which gives you more information about the mean, the occurrences, how many there are there missing values, that kind of stuff. And you have also a review tab where people can comment on the assets. The whole idea of this finding information of this catalog is figuring out do I have somewhere in my organization a data set that can help me to predict what I want to do. In this case, predict a certain IoT device. In this case, if I look at the data, I can decide, okay, fine, it seems okay, the data is available, I can use it, and I can really use it for my OT project I have here. In that case, you see the blue button on the right, I can add it to a project. Everything in the Watson Cloud Pack is done using a project where you can give people access to and where you can group assets together, everything that you use for like also models, notebooks, or combined into a project. The catalog itself, it's more enterprise-wide, but if you want to share information across the project, you can upload it again to the catalog, or different catalogs, where you can give it, or where other people can, outside of the project, might have a benefit for. Just as an elaboration, for data scientists, it doesn't really matter if there is good or bad governance, because that's not what their area is, but for a company, it does matter. So for that, it's important that the catalog itself is part of a broader governance portfolio. For example, which is combined with the business glossary, which has policy management, which has data quality checks. So everything in here, in Watson Knowledge Catalog, you can shield, you can see who can access it, you can also anonymize stuff. It's all available on the broader perspective. Of course, for data scientists, it might not be important, but it really does for the company. And this is where Cloud Pack for Data, of course, is the broader version of the Watson portfolio. So next step, let's drop first the define step. I'm going to first make a little step to the different modeling tools that we have. It's very important to understand that Watson is a multimodal development environment where you have actually everything going from a notebook, which is actually a development environment, where you can code. Being in data scientist world, of course, it's Python and R. That's for the real data scientist that will have full control of everything it has and uses notebooks to make your own models. The notebooks itself, everything in the platform is supported by Apache Spark, by the way, and so besides the normal traditional Python and R notebooks, we also have Spark environments that are available for bigger setups. In the middle, you have the Canvas approach, which is actually built on our product called SPSS. In this case, you actually visually build your model, and it allows for, let's say, the data scientist, or often use citizen data scientist, to create your own model without being fluent in Python or R or in Apache Spark or Sparkly or whatever. So you can actually, by putting some blocks, by configuring some blocks, you can create a model, and you can actually also deploy it. If you made it by notebook or a Canvas, it actually doesn't matter on the broader term in the deployment or making it available for outside. The last one we have is called Auto AI. And Auto AI, it means that you give the data to the tool. The tool tries to figure out what is the best model to use, the best preparation. I'll give you some overview in a minute, and spawns a model that probably is the best. Now, why would you not always use Auto AI? There are some things that Auto AI environment cannot do, and you see a difference. In the notebooks and the Canvas, I have data preparation business, you have data preparation technical. And the Auto AI part, you have data preparation technical. What data preparation technical means is that you go to technical things that you can do with your data, like, for example, missing values, normalization. There are technical things that you can do. What the Auto AI model cannot do is selecting the correct model parameters to feed to it, and that's business insight that you need. So even if you have an Auto AI tool, you still have some business insight. You need some business insight and to prepare your data before giving it to the Auto AI model. For example, you have 100 fields, but only maybe 20 are important for the model that you as a business user know. In that case, you're going to pre-select in the business preparation part those 20, and then you go to the Auto AI and let the Auto AI model figure out the best way to do it. If you look at the Auto AI model, how it works, it actually is the complete chain on automatic way. So the first thing, it will read the data sets. It has a split between the whole data and the real data. It will get the training data. It then will read the training data. It will pre-process it. This pre-processing is actually what I call the technical preparation, meaning null value suppression, normalization, that kind of technical technical stuff is done in the pre-processing. And then it will look at different models which might be interesting to do. In this case, of course, we talk about the classification problem, because we want to, based on the data, we want to select which IoT device is actually predicted based on the network data. But the model selection will then look in different solutions, different methods, AI methods that it can use to do this. In this case, for example, it has determined that the best way to do it is an RGBM classifier and a random forest classifier. That's the two methods it will try to use. And then it will create for both 4 models. The first one is a plain basic model. The second one is the basic model, and then it will apply hyperparameter optimization. The next one, it will do some feature engineering, but once again, feature engineering is technical feature engineering. It will use, it will combine the data in different ways with tangents and summations and that kind of stuff. Of course, it might be that it combines two values that does not make any sense from a business perspective, but actually create a better model. But that's a different way of looking at feature engineering. In this case, a pure technical feature engineering. And in a fourth model, it will also do the hyperparameterization on the feature engineering model that it used for the different models. In this case, you can of course customize it. We have 8 models, P1 to P8, and the star indicates which is the best based on what you have selected. For example, give me the model with the best accuracy. Once you have this, it will give you also information about all type of information about the accuracy and how the confusion matrix and that kind of stuff. And if you see it's okay, you can actually deploy it as an endpoint. It's also important that our AI modeling tool is not a black box, because if you want to do it, you can also export the Python notebook that's used behind the scenes. And the Python notebook can, of course, then, for example, be picked up by a real data scientist of habit and with some coding knowledge being adapted there and used there. So it's not because it's auto AI, we throw in some data, something comes out, it's a black box. You get for complete insights in the code. It's actually used to generate the best model. Just to make sure, there are different types of platforms. And for example, these are 2 forest wave graphics. And on the left side, you have what's called the multimodal environments. And the other side, you have the, let's say, the notebook-based models. And you see that IBM is actually there on the multimodal side, which has a notebook environment and programming environment at one side, but also a GUI-driven, a canvas environment like we have on SPSS, just to make sure that there are different ways and different platforms that offer different things. So I skipped a step, of course, and I already told you when I talked about auto AI, you can do preparation on a technical level, but you also have a business side, and you also have to treat your data before you actually give it to an AI model or to go into a notebook. Also for that, we have a tool. Of course, you can do it in a notebook itself. You can also use the GUI, the canvas, which actually also does this. But you also have a data refinery, which is actually a GUI that creates R codes based on Spark. It's actually Sparkly R that manipulates the data and creates a data set that can be fed to an AI model. It's actually a pipeline building. Okay, you see different things you can do. You can filter, you can sort, you can combine data. It's also giving you some insight in the profile. There is a visual component that can help you detect what's in there. But in the end, what you will have is a pipeline of different steps. See on the right, different steps that need to be done on the base data to actually generate a model, to create a data set that can be fed to either the notebook, either the canvas, or of course on the AI tooling itself. The last one, what you need to do is, of course, deploy a model, because only creating your model is okay, then you have created the model. If you cannot do anything with it, it's pointless to do it. So in this case, we might create an endpoint where we can feed in where you can put up an application that can use this model to work, let's say, in a dashboard or in an application itself. You see here, there is also a way to test it. If once you have deployment, you give it some data, which is in JSON format. On the right side, your result is coming back. In this case, I fed in three network specifications, and it predicts that it's a baby monitor, a security camera, and a smoke detector. And the idea is that the application will compare it with what it should be. For example, if the first one is a baby monitor, but it's something different, you might say, okay, something, it seems to be that it's kind of hacked because it's spawning odd network data, completely different what would be expected. So to make the whole picture, we have the different services that are connected together. At the left side, you have the Watson Knowledge Catalog, which I talked to you about finding your data, managing your data, governing your data. The Watson Studio part is the builder part, where you have the canvas, we have the notebooks, we have the data refinery. And the Watson Machine Learning is a deployment part, where you can deploy your model either as an API or, for example, also as a batch scoring endpoint that you can use. On the right side, I didn't talk about that yet. That's actually the monitoring part, which is a product that we call Watson OpenScale. And I'm going to talk to you a little bit about what that does. But first of all, I'm not talking about the complete life cycle yet. Actually, the life cycle itself is much broader than actually the CRISP DM life cycle. What we have talked in this case is the right side of the line 8 that you see there. It's creating a model. But actually, your model creation, because it will be built in some applications, it has to be built into a CI/CD pipeline, which CI/CD pipeline, which of course is something that developers are well known on, deploying new code. And because you actually create new code, it has to be put it in there. And there we have the different cloud packs. The right side, the blue part, is the cloud pack for data, what I showed you. And on the right side, you have the cloud pack for applications, which is actually supporting the CI/CD pipeline. And of course, it must go from one side to the other, and that's what also Cloud Pack makes available. It's much broader than only the AI life cycle, but much more. It's actually a more complete deployment life cycle, the application life cycle. So back to the monitoring part. This is a GUI that you can see when you use OpenScale, and of course in the middle you see the quality, which is of course a very important one. Once you have deployed your model, over time your model will degrade because new data is coming in, and the predictions will probably become a bit stale or become a bit different, and it's very important to keep an eye on it. In this case, OpenScale allows that you can monitor, let's say, deployed models and see if the quality, the accuracy, or whatever you want to measure. You see different measures like precision, F1 measure. When it becomes below a certain threshold, you can, for example, kick in a retraining. On the left and the right side, you see two other things that are important. The fairness part, which might not be that interesting for security, let's say, tooling. Fairness is, of course, important when you work with models that are, for example, scoring people. You want to be fair, meaning that you not want to discriminate based on, for example, age or race or on age. That's are things that you can check. Also, OpenScale is capable of monitoring that kind of unfair treatment. For example, you have a model, it's clearly biased, that giving men, for example, a better outcome than women. So that might be detected. Keep in mind that fairness is not a fixed asset, but it's actually something that can change over time. I come back to that in a minute. On the right side, you have something that's called drift. Drift detection is also a concept that I will explain in a minute. What is drift? Drift is actually changing the nature of the data when new data comes available. I'm going to make it very visual. Imagine that you have created a training model that predicts if a car is on a certain picture, for example. Now, once it's deployed, people start also to use this model to score, for example, trucks. Now, a truck is a car, but not a car is such. It's not the same as the data, the training data. Now, if people start to do that more and more, you see there's a discrepancy, a difference between the actually incoming data, which contains cars and trucks, and the training data, which only contains cars. And this is called drift or data drift. And it's important to detect this, that the incoming data changes is different from the data that is the model has been trained upon. If there is a difference, a big difference, the conclusions of the model might be wrong just because of, it has not seen the training data it's actually now treating. So that's data drift. It's also an important factor that you have to keep an eye on. Based on the fairness part, this is a more global area. Of course, it's important that your model in the beginning is fair itself, and your data scientist can help you there. There are different methods to check even a model during development that it's fair. For example, it does not contain an age bias or a gender bias. Now, it's not a point of OpenScale to do that. That's a completely different area, and we have there is an open source toolkit which is called AI Fairness Statistics, which was built by IBM, but has been given to the Linux Foundation, that contains a lot of toolings and ways to monitor, to check fairness before the model is deployed. But once the model is deployed, because of the changing data, the model, even initially being fair, can become unfair over time. And that's where OpenScale comes in. And OpenScale will log all the data, provide check for unfair, for bias, for unfair bias, for example, based on age, based on gender, and also provide a debiasing mechanism. So if you want to use it, it will expose two APIs, the normal API and also the biased API. So in that case, for example, if there's a bias detected because the model has has an age bias, you can say, okay, I will use the debiased endpoint, which score me the best solution for a certain group. For example, younger or discriminated, it will give you the outcome from the older generation. What you also see there is that the monitoring is not only limited to the IBM stack, but is also able to monitor models that are deployed on Azure or on Amazon, and even custom. The only thing we need are two endpoints to allow scoring and to detect this fairness or of drift detection and things like that. Just something that's also quite interesting for in the security world is the concept of federated learning. Also, Watson Studio is able to do that. Federated learning meaning that you create a model based on different data sets, but you would not allow to share data sets with each other. For example, if you have three companies in this case that are willing to work together to create a good model, but they all have the data, but they cannot share it with each other, then you can use the concept of federated learning, where actually the data is treated completely confidential. Models are built on the back end, but there is one general model that is created based on the models that are below that. So also, I'm not going to elaborate more on federated learning, but it's also available in Watson Studio. Next, I want to talk about, let's say, AI solutions, which might be interesting. These are chatbots and search engines, which actually are instantiations of natural language understanding, natural language processing environments. So Watson Assistant is our complete solution that allows for chats, to create chats on any information that you want. It's also integrated with our speech to text and text to speech, so you can also talk to it if you want. But it's also have a very easy way of designing. It's more focused on, let's say, the SME, the subject matter expert, than on the hardcore chatbot creator, which uses code. It actually uses building blocks that helps you to create a certain chat. You can also get information from it, giving, let's say, gather information from it. For example, booking a table in this is a typical example. But for example, in the case of security, you can say, okay, can you give me the logs of that? Which type of logs? And it can go to the data set and give you the data. That kind of communication is also possible. It's also important that you can use the assistant to connect with external tools that you see on the top side, integrations. For example, looking backend searches, looking connections with other systems that they can give you some say information that can be useful inside your chats. Now, a chatbot itself is nice, but a chatbot is only able to do what it is programmed to do. So if you put it in the conversation, it will be able to respond, but if it's not if you're not programmed to do it, it will not be able to respond. So the idea from IBM is to give you full set. So to only use the chatbot to always say 80% of the question, to solve in 80% of the questions that you program that in the chatbot. The long tail, what you see in the middle, is what we have, what you should cover with a search engine. In that case, we have Watson Discovery. Watson Discovery is, you can talk to it in natural, you can actually talk to it in natural language understanding. You give it just the text, and it will come back with a good answer. Now, what's the combination of the two is very, very powerful, because if the chatbot does not understand your question or not a good answer, it will forward the text to our Watson Discovery solution, which will generate a list of good answers. And it's also possible to even try to pinpoint the answer. For example, if you ask how many logs are available, and it's something is hidden in certain text, it is able to pop up with the number 5, because it's somewhere to highlight the 5. It's okay, it's 5, rather than so it's somewhere in this snippet. The last part, of course, you see the agents. So, and what we have here is a complete cycle. We use the chatbots to cover 80% of your questions. The next almost 20% you will do with the search engine, which will provide the answer that the chatbot cannot answer directly. And in last resort, you can also contact an agent. You see, we integrate with a lot of agents that are available, like Zendesk, Genesis, and that kind of solutions. Now you're going to say, okay, our chatbot, how good is it? And our search engine, how good is it? It's, of course, trained on general English. But if you really want to make it product specific, we have also a tool that's called Watson Knowledge Studio, that you can learn the lingo of your domain. In cybersecurity, you could, for example, learn terminology that is used in cybersecurity and how it works together with other technology. Because a certain term that in general English means something, maybe in cybersecurity will mean something completely different. And by using Watson Knowledge Studio, you can actually learn, you can enhance the NLP and NLU processing behind the scenes, and you can use that in your Watson Discovery to actually really get more valuable information based on your domain in your answers, and that you can, via a search skill, also expose in Watson Assistant. So as last part, if there are no questions, I will talk a little bit about AI as an attack surface. AI itself is powerful, and you can use it to detect threats. But of course, you can also attack it, and and hackers will do this and will attack you, but also attack your defenses. In this case, your AI. So, what I'm talking about? This is a common example from a few years ago, where the Tesla computer was actually tricked to see something that was not there. So the Tesla autopilot normally is created to keep the car safe and to keep it on the lane. But of course, if something happens on that lane, it will instruct the car to diverge from the lane and go to the other one. Now, researchers have tricked the ones by just putting 3 simple stickers on the roads by an adversarial attack, and that tricked the autopilot to see something huge on the street, and actually it changed lane. Actually, there was nothing happening, but it was tricked to see something. Now, I'm not picking on Tesla here. The problem is here not that it's possible. It's always possible. You can trick any AI system. The point is here that it has been tricked on a very simple, undiscoverable way. If you have to trick a model by building a very complex construction in the middle of the road, a human being will also see that something is wrong. The point here that there were only three simple stickers on the road that actually tricked it. So it's not that it's not possible, it's always possible, but it's the invisibility that is not, that's not a good thing. Some other examples, what we call this concept is called adversarial attack, where you try to figure out to change the environment in such a way that the AI is strict, but also in a way that the human being is not cannot see. And it's of course very easy when you work with pictures. On the left side you see a snail. By putting some very specific noise, because it has been calculated, of course, and then the AI will see a mitten, but we as a human being still see a snail. It's the same thing with noise. You can put in some unhearable noise inside some speech, and speech recognition can hear something completely different than what's actually in there, while we as a human being are still able to hear the text as is in there. On the right side is also another what you figure out in real world, where a stop sign is manipulated in such a way by putting on stickers that the AI saw that there is saw actually a speed limit of 45 miles per hour. So once again, the point is not that this happens. It's always the case because it's a mathematical model. If you have actually an AI model is a big function. So if you have a big function, you also have an inverse function. By using this inverse function, you can manipulate it in such a way that you can see things that are there, that are not there, but are actually, that AI can see it. So one of the big threats is that you actually do not need access to the model itself. And there's some study been done on something that's called transferability. It actually means that you don't even need to know the exact way how the model is built. So what have they done? So imagine that you have a model, and I'm a hacker and I want to break the model. I want to figure out, I want to create an adversarial attack against your model that you have there. Then you should say, okay, I need to know it, but actually it's not the case. What I can do, I can try to get some data points. I give some information and I receive the end result back. And I can do it in such a way that I'm not creating some kind of suspicion. Just one at a time, I can gather some information. And what I can do based on that data, I can generate my own model, a substitute model. Now, what has to be tested is that by creating an adversarial attack on that substituted model, that it's also able to trick the original model. So, and that's of course the biggest threat, that you do not need that much information, according to the study, to actually create an adversarial attack on an existing model that's open to the internet. Adversarial attacks are actually let's say come in different forms, and it's actually a format what is called evasions. We have false positive evasions, and that's an adversarial attack where you try to gain access in something that you do not want. In this case, you're positively identified as having access, but you don't have actually access. You also have false negative evasions, which is also kind of an adversarial attack. For example, that's avoiding detection, that you, for example, in the street cameras, that the cameras are not detecting you. You're still there, but the things are not there. But there are other threats which are that AI exposes. One of them is inference. Another one that I will talk about is poisoning. Inference is trying to get information for the model that's hidden in there. And one of the threats, and certainly if you go to, let's say, GDPR and that kind of stuff, privacy stuff, is, for example, membership inference. The idea is I have a picture for somebody, and I ask myself, is this picture used to train the model? And that's what membership inference is. You try to figure out, you get a yes or a no, this picture is used, or this data set is used to create a model. And that, of course, gives me information on the underlying workings of the AI model. And even more threatening thing is what's called model inversion of input inference, where you actually, based on by tricking by asking questions to the model, to the neurons, to figure out the actual data that's hidden inside those neurons. So on the left side, you see, on the right side, you see the original picture where it is trained upon. On the left side, you see something that's gathered from the neurons from the neural network, and you see the kind of resemblance. So in this case, you can get information from a model, even if you don't have access to the original data sets. The last one is model poisoning, and that's different from adversarial attack. In adversarial attack, what we see on the left side, what you do there is you want your data points. For example, I want to be hidden in a camera. I want to get my data point from my person, and I want to get it on the other side of the boundary. In this case, I want to be that my picture is recognized as a green one, so that it's hexes. That's what an adversarial attack is. In data poisoning, it's actually what you change is by manipulating the base data. I keep my data point there, but I try to influence the decision boundary. In this case, you see, by shuffling one of the orange dots, I'm able to shift the decision boundary in such a way that my data point is actually coming on the correct side, or the side that the hacker wants. As I told you, adversarial attacks or others are there to stay. You cannot avoid them because it's a mathematical process. The only thing you can do is make it more robust. What robust means is that if the model is strict, that it's also obvious for a human being, because that's the whole point of it. One thing about the car I explained there, if you have to construct a completely strange posture in the middle of the road, it is obvious for a human being that something is wrong. And that's how you have to make your models more robust, meaning that you have to put in there, make it that strong that when it's manipulation, that is really obvious for a human being that something is wrong, rather than it is becoming invisible. My last thread, but that's really something where people have to look in. It's what's called the deep fakes, and that's changing reality. This is a nice video from David Beckham that is making an advert against malaria in 9 different languages, and really David Beckham is fluently in those 9 languages. Now, of course, David Beckham is not fluent in that 9 language. It created a deep fake. Now, this is for the better. Of course, it's nice, it's funny, but of course, you can also use these deep fakes to create reality that's not there. And it's such a threat, actually, that people are now trying to figure out ways to detect those deep fakes. One of the things, for example, from last year is where AI models are detecting a heartbeat in a video to detect if it's a deep fake or not. But even in that case, if we can detect heartbeats, of course, also that can be faked, that can be made. But it's something that we need to keep an eye on. Now, if you want to test all those tools, the easiest way and let's say the cheapest way is to go to our clouds. You see the URL on the top. We have, for all the tools I've showed you here, we have light versions, free versions. You see the Assistant, the Discovery, but also the Studio, the OpenScale. They're all there for you to use and to try. And all these tools are also available on other clouds via a cloud pack for data deployment. But if you want that, for example, if you want to use those tools on Amazon, Azure, or Google, or even on-premise on your own OpenShift, you can also always contact me, and I can explain you how you can do this on those platforms. That was my story. Are there any questions?
It's quite a story, Stefan. So it's been very interesting, and thank you very much to take us through that journey. I think that's been extremely helpful for people in the cybersecurity arena to understand how to start. Especially also, of course, the last point where you indicated where we have to go to and launch our own startups. But I'd say in terms of questions, the biggest question that we would have is in the different components and tooling that you presented, are there some use cases and example components available that we would be able to start utilizing on the basis of, for instance, log data that we can gather out of. Let's take it for an example, QRadar. So QRadar is being utilized by our systems. We get the SIEM information, and we can basically drop it in the way that you showed. So taking the different steps and then going forward. And so, are there already components that we can reutilize from what you've shown?
Well, it's actually, I'm not the person who can answer that. What I presented here is actually the general tooling. But QRadar, for example, has a Watson component already built in. But I'm not a specialist in QRadar or other tooling. So our tooling also use Watson in the background. So what I'm presented here is just, yeah, this is the general. You can use it for everything. You can get some samples from internet, from Git repositories, and you can all use them here. But if you want to very specifically talk about integration with, for example, QRadar or security, I propose you to talk to my colleague Erwin Frithoff, who is our security guy, and you can say, okay, what is available from the Watson component in the QRadar suite, for example.
Yeah, and we will definitely do that because it's actually planned for a next session here as well, is to deep dive into the QRadar environment and the cybersecurity tooling in the cloud that IBM has, and where maybe we can also build upon in the same context as would be building upon the AI tooling itself. So thanks to elaborate on that. Another major question, of course, is about cost. What is it that we would be typically looking at in terms of different components? Because I think some components are more infrastructure related, some others are more platform oriented, some others are more SaaS oriented. So what's the how does it work, and what's the typical setup, without, of course, having to go into detail, but giving a bit of an oversight?
Of course, it depends on where you use these tools. For example, if you use the native one on IBM Cloud, then you are coming into a cloud, let's say, licensing mechanism. So some of them are, you have an instance, another one you have the number of calls, number of users. It depends on actually the tool. But of course, there are also, let's say, cloud prices. What I mean, okay, sometimes peanuts, but I give you an example. For example, if you use OpenScale, OpenScale is monitoring the models by using the API endpoint to check if it's okay or not okay. For example, if you do that if you monitor that on an IBM model, you will not bear a cost for that. Of course, if you use that for modeling an Amazon model, you can do that, but of course it's a call to Amazon, and Amazon will calculate. It's an API call, so you pay for that. So it's also depending on how deployment is. It's a different concept if you go to the cloud pack environments, because then we are coming in the area of an infrastructure, whether OpenShift, Kubernetes, let's say that's infrastructure. For example, if you want to have these tools available on AWS, what we actually use is a Kubernetes environment on AWS where we deploy this on top of it. And then you have the traditional computing VPCs, virtual computing power that's in there. So that's different calculation area. And of course, you bear also the cost there in that case for the Kubernetes environments on Amazon. So it really depends on where you want to deploy it. So the cheapest one, as I said, is IBM Cloud, the native one, the light version, because that's cloud prices. If you go to the cloud pack version, okay, you're coming to more traditional VPC pricing.
What about storage in this case? Because of course it's not going to be storage per se, but at least there's going to be data transfers, even the metadata being sent over for then the system to start doing its analysis. So what about that?
But that depends also, once again, on where you deploy it. For example, on the IBM Cloud, there is no payment for transfers, but of course, I know there are other cloud providers that are doing this. So if you do a cloud pack on an Amazon or Azure, that might imply costs over there, not from our products, but over there. But as far as I know, in IBM Cloud, there is no data transfers internally. You do not pay for that. What's backing this up is an S3 compatible storage, IBM or whatever, and of course there we have again the cloud pricing, which is peanuts. This whole project information, that kind of stuff, is just stored in an object store that's available.
Okay. Well, thank you very much for all of this. I think in our next session we'll be inviting you back, Stefan, with some of our use cases, and then trying to elaborate them a little bit further in how we try to deploy them into the IBM cloud environment, utilizing some of Watson's capabilities. So with this, I'd say a couple of things for me to round up. But in any case, thank you very much for doing this here for us today. I hope you haven't basically melted down.
Not yet.
So a couple of slides basically to round up, because obviously what we'll be doing going forward in the next couple of weeks, and I'm looking likely within the next 3 to 4 weeks now, is taking a similar type of example and trying to investigate, okay, what are the different pricing models that we have to take into account. Also analyzing, like in this case, for instance, the economic performance specifically between some of the different cloud operators, and what is actually the impact on this if we take that on a monthly scheme. So just as a sort of indicating the way that our analysis is going to run in the next couple of weeks, and so by basically investigating and inviting some of the other potential cloud providers to work in this case with us. So CSAI is a cybersecurity icon project, which was made possible thanks to the thematic icon projects of LIO, the Agentschap voor Innoveren en Ondernemen. So thanks to the Flemish community. And so with this, we obviously like to thank, in the first place, Stefan, to do this, our different partners from the CSAI project. And I would like to thank, of course, all of you to participate and to be interested in our indications, and also do continue to follow us in this and the next sessions, and also make sure that you follow us through in the next coming months and weeks, when we are taking the next steps and discussions on this activity, and potentially also on other activities. So thanks a lot again for participating and for viewing this webinar, and looking forward to seeing you again very shortly. Bye. Bye, Stefan.
Bye.